Hello guys, how are you? Hope you guys are doing well. Today we are going to discuss about vector analysis, the product part. Now, we all know that what is a scalar quantity and what is a vector quantity, right? A scalar quantity is a quantity that has only magnitude and no direction, but it is a vector quantity in which we have both magnitude as well as direction. Today we are going to discuss about the product part. Now, we have four type of products in vector analysis. Mainly three type we will going to discuss. We will be going to discuss, and we will be further dividing this third part into two sub part. Number one, scalar, scalar. Number two, scalar with vector. And number three, vector with vector. As we have said that we can further divide this vector product into two subparts. Vector dot vector, and number two, vector cross vector. So, now we will be delineating about all these types of vectors in vector analysis. Let us first start with scalar vector, scalar product, sorry. Scalar means it has only some value. Let us take 3 and 9. So, what will be the result? It will be 3 into 9 equals to 27. So, scalar with scalar product returns a scalar. Okay. Now, we will be discussing about scalar with vector. We know that scalar has only some magnitude, right? Let us take this magnitude as A, and this vector, let us take this vector as V. Now, V can be written like, three-dimensionally written like Vx I cap plus Vy j cap plus Vz k cap, where Vx, Vy and Vz are the components of vector V along x, y and z axis, and I cap, j cap and k cap are the unit vectors along x, y and z axis respectively. So, what will happen when we multiply A, this scalar quantity, with this vector? A V equals to A Vx I cap plus Vy j cap plus Vz k cap. We will just multiply this and get A Vx I cap, A Vy j cap and A Vz k cap. So, here it only returns some scaling up or scaling down of this original vector V. Like, suppose we have vector V, mod of vector V is like this, and when you multiply A with vector V, then only this magnitude will increase, but the direction of AV will be same as that of the original vector V. Okay. Let us move forward with the third topic. that is 3 part 1. What is that? Vector dot vector. You all know that we have two types of vector products. Number one, vector dot vector, and number two, subpart 2, 3 subpart 2, it will be discussing later, that is vector cross vector. First we will see what will happen when we dot product two vector quantities. So it is known as dot product. Since we use this dot sign over here, it is also known as scalar product, since it returns a scalar quantity. So when we dot product two vector quantities, then we will obtain a scalar quantity. Okay, let us discuss about that. Let us take two vectors. Now, in this tone, I will also like to discuss that A dot B is written like mod A mod B cos theta, where theta is the vector, theta is the angle between two vectors A and B. So what will happen when we dot product two vectors? See, we have 9 products. Okay, first Ax Bx I cap dot I cap plus Ax By I cap dot J cap Ax Bz I cap dot K cap, and likewise Ay Bx I cap dot J cap Ay By J cap dot J cap Ay Bz I cap J cap dot K cap plus Az Ay Bx, okay, Az Bx K cap dot I cap plus Az By K cap dot J cap plus Az Bz K cap dot K cap. Now see that when we dot product to same type of unit vector, like using this formula we will have, it is unit vector, that is mod equals to 1 and angle between them is cos 0 degree, that is 1 1 1, and answer will be 1. But when we dot product to different kind of unit vectors, we will have 1 like I dot j cap, I cap dot j cap will have 1 1 and cos theta will be here 90 degree, right, cos 90 degree. So answer will be 0. So we will obtain here only this and this. All the other components will be, all the other products will be cancelled out. So we have AX BX plus AY BY plus AZ BZ. Okay. So what we have to do? We just have to multiply just component wise. AX BX, AY BY and AZ BZ. And that simple it is. Okay. Now, hope you have copied it, right? Now we will be moving forward into cross product. Okay. You can also pause my video and take a screenshot of this screen. Okay. It will be beneficial for you. Now we'll be having vector cross vector. It is known as cross product since we use here this cross sign. It is also known as vector product since when you cross product two vectors we will have a vector quantity as result. Now what is the direction of this vector? We can write A cross B as mod A mod B sin theta n cap. Here this unit vector denotes the direction of A cross B. Let us take this vector as C. Now we need to find out that what is the actual direction of this n cap vector which reveals the direction of this C vector which is none other than A cross B. Let us have two vectors A and B having theta angle in between them. Then if we can apply right hand screw rule and we rotate it from A to B or right hand rule, like we can bend our fingers from A to B, then our thumb will indicate the direction of vector C. So what is the direction of C? It is in the perpendicular direction to the plane containing both the vectors A and B. Okay. Now what is the magnitude of it? That is A B sin theta. The magnitude of C can be obtained by using determinant rule. Mod C or mod of A cross B or is obtained by, let us take two vectors again, A equals to AX I cap plus AY j cap plus AZ k cap and B equals to BX I cap plus BY j cap plus BZ k cap. Then we will obtain that mod of C will be I cap, j cap, k cap and AX, AY, AZ, BX, BY, BZ. We have said that we can obtain mod out of this, but eventually we will obtain not only the magnitude but also the direction out of this determinant rule. But this will be getting more clear if we can discuss it with an example. We will be coming in next video with some example and problems regarding these vector products scalar products, vector products and all in the upcoming video. So stay tuned with this channel and please do share this video. Till then, bye.